So as you know, I've been struggling with the whole wiring thing, basically unsure of where to place things and finally solder things, and I've been making great use of the breadboard, in the meantime. On that same line of thinking, I wanted to take a kind of a tangent away from the sensor stuff and tackle the I2C communication between the Arduino MEGA ADK board, which is going to be ultimately connected to the Android tablet, and our Android Uno. So if you're not familiar with I2C, basically it's the communication protocol between Arduino boards. Or it's used for the communication between the Arduino boards. And what that allows us to do is essentially kind of grow our number of pins and our capabilities in terms of handling more stuff. For example, the different sensors. So if you were to have just one Arduino, you're kind of limited in terms of the number of pins. You can of course just have the Mega, which has a lot more pins, but hey, more is better. So this gives us basically the ability to expand on the Arduino architecture and kind of have more room. There's also the issue of memory. So if you have just the Uno, which has limited memory, I can't remember what the amount is right now, the Mega has more. More is better, so 2 boards better than 1. So yeah, so basically rather than trying to show you the wiring on the breadboard, which is right now kind of like a spider's web, I thought I'd show you some schematics and kind of talk you through it. So let's take a look. I hunted around on Google Images to find a good example of the wiring for the I2C protocol, and this is one of the best ones that I found because it's so simple. So basically what you want to focus on are a couple of things. So you see that the yellow wire and the blue wire, those are your, what are they called? SDA and SCL pin outs. So basically they connect from one Arduino to another, and it doesn't matter whether you have 2 like this or whether you have many more. Basically, and it also doesn't matter whether it's your master or your slave. Basically, you want to connect each of the SDA pins to the respective SDA pins on every other Arduino, and similarly for the SCL pins, you want to do the same thing from one board to the next. The other thing that you'll connect is your ground pins will be connected. So ground goes to ground from one board to the other. There's nothing between them. Basically, it's straight connection. All the ground pins get connected. Then from your master, you're going to take your 5-volt line, which is this red line here, and you're going to plug it into your VIN. I accidentally originally made the mistake of putting the 5 volts to 5 volts. It actually still works, but it gave me a bit of kind of power up issues on the slave board. So basically you want to put the 5 volt out on your master pin going into the VIN, voltage in, on the slave boards. The other key thing here are the resistors. So there's some dispute online whether you need them or you don't need them. I'm going to use them because I think they're kind of better safe than sorry. Nobody seems to think that it's a bad thing to use them. Basically the discrepancy is recently the understanding is that the newest boards have these resistors built in, so you don't need to put them in yourself. My boards actually are from a couple years back, obviously, so I'm not actually sure one way or the other, and I'd rather just play it safe than sorry. But basically your resistors go from the 5-volt line into each of the SDA and SCL lines. So basically you want to put a pull-up resistor between the 5-volt and your blue line, and the 5-volt and your yellow line. So basically you're sending power into these lines, but through the resistors. And that's pretty much it. They also, basically the argument is kind of start with about 4.7 kilo ohm resistor, but you can adjust from there downward if you're finding some communication issues. A lot of people don't put the resistors in and claim not to have any problems anyway. So give it a go. And but this is the best example, visual example that I could find. So hopefully that helps. It certainly helped me. So let's take a look at the code. So I went around looking again for example libraries and codes and that sort of thing to get started. I actually still have my code from 2 years ago, which is full of a whole bunch of extra stuff because I had the communication already working with the Arduino tablet. So rather than pulling up that old stuff, I wanted to start with something really simple and just kind of proof of concept, make sure that the two boards are talking to one another. So here we have the kind of the UNO side of the conversation, what they call the slave code. So basically we're defining an address for the slave. Like I said, you could have a lot of these quote-unquote slaves, and we're then just, it's all very simple. I want you to ignore for kind of general purposes. In the case of ROVer, we've got the relay board, and I wanted to include code that basically ensures that the relays stay off. I kind of want to focus on just the I2C communication. So basically we use the wire library, which we've included up here, and we have two different functions that we make use of within that library, the onReceive, the onRequest. And basically the slave is going to make use of these functions as when it receives a request from the the MEGA ADK board, the master in this case, and then when it receives that request, it's going to respond with this value here. So let's take a look at the other side of the conversation, the master. So the master, again, you have to define the same address so that they know where each other are in this whole thing. And basically this goes through the kind of the general setup. We're going to write the same hex value that we've defined up here. And when the UNO, the slave, gets that request, we're then going to read that from the serial and print it out. So I've already uploaded this to each of them, so I'm just going to connect the USB cable to the master. So the power lights have come up on, you see here that the creator here recognized the MEGA ADK board. The power lights have come on both boards, so that's great. And now if you flip over to the serial monitor, you see here it's telling us what value it's sent, that it's requesting data, and then reporting back what the slave sent in response. So far so good. And I'm going to disconnect the master USB cable, and I'm going to flip over to the slave test, connect the USB cable for that one, and we've got the UNO recognized. If we flip over to the serial monitor, so we see here that it's reporting back the value received from the MEGA ADK board and what value it's sending in response. So we've got communication going back and forth, which is exactly what we wanted. That was kind of just an aside, but I'm glad that we've got those pieces in place as well. I've been trying to figure out where to, you might have seen in a previous video, where to position the MEGA board. And I think I'm going to have the MEGA on the kind of the base floor of the ROVer with the UNO positioned above it. It's not really going to be like a shield. They're not going to interface with one another. I'm just going to have standoffs. But really, it's just a matter of kind of space conservation within ROVer's body. So that was kind of the primary purpose of connecting those two at this point, really just getting the wiring in place. And yeah, I guess really the next step is what I've been procrastinating on is soldering wires and making things more permanent, and then retesting to make sure that I didn't screw it up. I do want to tackle the last sensor, last type of sensor that I want to do at this stage, which is the ultrasonic sensor. I've got a few of these to play with, but I want to connect one of those up, so that might be the one last thing I do before I start soldering. Again, just so I kind of understand the overall layout of the components and what they require from each of the boards, and then I'll just have a little bit more confidence in how to make things more permanent. So if you're interested in the ultrasonic stuff, stay tuned. Until next time, cheers.